This example comes out of section 8.2, transformations of log functions. So in this question we're given some information about a welding helmet. I don't expect that most of you probably know any more about welding helmets than I do, and I don't claim to know any more than anybody else. But we're given the equation here that says n equals 7 times negative log of t divided by 3 plus 1. N is, we're told, is the filter shade number, a number that goes from either 2 to 14. And t is the fraction of visible light that passes through the filter. So you've got weaker and stronger filters depending on what kind of welding you're doing. What we're asked is what fraction of light passes through filter shade number 13. So what fraction of light passes through filter shade number 13 means we just put in 13 for n. We've got 13 equals, and we just write down the equation as it was. Now we're trying to solve for t. This is fairly common where we have one unknown, we're given the other one, and we're just basically doing the algebra to solve. First step is pretty easy in that I subtract 1, so I've got 12 equals negative 7 over 3 log of t. You notice I changed the 7 negative log t over 3 to negative 7 over 3. It is the same thing, just makes it a little easier to see what I need to do next. I'll multiply by 3, divide by 7, make it negative, so I now have negative 36 over 7 is equal to log of t. A lot of students get stuck here because they don't know what to do. They do some very unusual things with this log. Remember that it's log base 10. So what it means is that 10 to the negative 36 over 7 is equal to t. So it now becomes kind of just a calculator job to say what is 10 to the negative 36 over 7. And if you crunch those numbers, you get something like 7 times 10 to the negative 6, which is not very much, as you can imagine. If you wrote that in decimals, 0.000007, and there were more decimal places, 7.2 approximately. So if you're using this welding helmet that's in filter shade number 13, you've got some tiny fraction of visible light that's passing through that helmet.